Greetings, math fans. All right, so this is day 8, and we're going to talk about today our basic differentiation rules. Okay, so a couple things to remember. So remember what a derivative is. Right, it's a slope of a tangent line. Right, tangent of line of some function. Okay, so let's look at some. Let's look at some derivatives. Well, we have done that a lot of those using limits, right? Okay, but just kind of understand the basic concept here. How about y equals 2? Okay, what is the derivative of y equals 2? Well, remember, it's a slope of the tangent. So isn't that equal to 0? Because isn't that y equals 2? Isn't that a horizontal line? Isn't the slope equal to 0? So that's the answer. The derivative d by d, or dy dx of 2 equals 0. It's interesting, very interesting. Okay, let's try another one here. Another example. How about y equals 2x? What's the derivative of that? Well, again, we use limits to do that, but think logically. Well, isn't this just a nice straight line here, right? Is that nice? It's linear, right? And what's the slope of that? The slope of that tangent line, any tangent line on there, right? It's going to be on that line itself. Isn't the slope equal to 2? Well, that's because, right, we have y equals mx plus b. You guys know the slope is 2. Okay? So that's just kind of a basic knowledge of differentiation. You guys already know how to do something linear and something with a constant. All right, so let's now talk about something called the power rule. So we're going to do the proof of the power rule. And when you learn this, you will be very powerful. All right, what you want to do is you want to make 3 columns here, math fans. You want to write here the value of n, and then you want to write x plus h to the n power. What does that equal to? That's going to be kind of a big column, so leave a lot of room for this column here, okay? And then you're going to do x to the n, and that's going to be a little column also. All right, so value of n is when n is 1. Do you guys agree when I put a 1 in there, I get x plus h to the 1, or x plus h to the first power? Okay, well, that's pretty easy. If I do n equals 2, I get x plus h quantity squared, and I'm going to write this out as then, when I FOIL it, I get x squared plus 2xh plus h squared. And then x to the n is just x squared. So we're going to do it for 4 of these, so bear with me. N equals 3, we get x cubed plus 3x squared h plus 3x h squared. It's going to be third power. We have n is equal to 4. We'll do the last one. Got to crunch it in here. It's going to be x to the 4th plus 4x cubed h plus 6x squared h squared plus 4x h cubed plus h to the 4th. Okay, it's all expanded. And then, of course, this is just going to be x to the 4th power. All right, so let's take a look at, again, we're going to kind of have to, it's a little crunchy in here, but I want to take a look when, we're going to keep this here, when n equals 4. So I want to say my function is f of x equals x to the 4th, and I want to take the limit of that, or find the derivative of that, okay? So it's going to be f prime of x, I'm going to write a little smaller here, is equal to the limit as h approaches 0. It's right using our definition of the derivative. And of course it's going to be, you know, f of x plus h to the fourth power minus f of x to the fourth power over h. All right, and we plug that all in, and so that's how I'm going to use this line right here, math fans. Okay, x plus h to the n power, it's just going to be x to the fourth plus 4x cubed h plus 6x squared h squared plus 4xh cubed plus h to the fourth all over h. Okay, and we need a limit. I just run out of room here. Limit as h approaches 0. Okay, and then what am I going to do is these guys, do you guys agree? Oops, I'm sorry, then I forgot my f of x. So minus x to the fourth. And then these cancel. Okay, the x to the fourths cancel. So I wind up with f prime of x is equal to, then I got to factor an h out of here. So I'm kind of do a few steps here. I get 4x cubed plus 6x squared h plus 4xh squared plus h cubed over h, and they cancel. And again, this is limit. Okay, they cancel, and now I do direct substitution. So do you guys agree that basically this guy right here, that all cancels, and I wind up with just 4x cubed? So that's what f prime of x is. Okay, 4x cubed. And that's kind of interesting. So my original function, remember, was x to the fourth, and now it's 4x cubed. All right, so I want to leave all this information in the box on top here, and I want to do a general rule. So I'm going to erase this. Okay, so let's move this up just a little bit, and let's do it in general terms now. All right, and we're going to do f of x is equal to x to the n power, and I want to find f prime of x. So f prime of x equals the limit as h approaches 0 of x plus h to the n power minus x to the n all over h. All right, and a couple things I want to point out here, math fans, about coefficients. You guys know when n is equal to 2, see how that first, or really the second term has got a 2 here as a coefficient? When the exponent is 3, n is 3, it's got a 3 there. When n is equal to 4, that's equal to 4 there. That's actually going to be pretty significant what we're going to be doing. Okay, if we keep doing n is 5, it would be a 5x to the fourth, and 6x to the fifth, and it would keep going. All right. So if I now expand this, okay, that's equal to f or f prime of x equal limit as h approaches 0, and it's going to be x to the n, right? Plus, and do you guys agree that, remember I told you that 4 went with that 4, so that means my exponent is n, so do you guys agree it's going to be n, and isn't it 1 less, right? See, this is 1 less, 1 less, 1 less than these, n, x, and then this is going to be n minus 1, okay, times h. Do you agree with that? And then this is the deal. There's a whole bunch of terms here. These are terms with x and h. And in this case here, it's going to be something with an h squared, h cubed, all the way, keep going, and it's, you know, x to whatever power right here, okay? So the whole point, and then of course my minus x to the n power. And this is all over h. So f prime of x is equal to limit as h approaches 0. Now this is the deal, math fans. First of all, this guy and this guy cancel, right? The x to the n's cancel. And the reason I kind of separated the nx to the n minus 1 times h, that had just an h to the first power. Everything else is h squared. All right? So when I want to factor stuff out now, right? I want to factor that h out of here. So I have h times nx to the n minus 1 plus all those terms, and it still has an h in it because right here is an h squared, so it's still terms with x and h. Okay, all over h. Of course, the h's cancel, and then when I do direct substitution, what happens? Well, because I have h's left here, all these terms go to 0. And the only thing I have left over is this guy right here. And that is my general term. So here we go, math fans. F prime of x equals, again, with direct substitution, I don't have to worry about that h, right? It's just n times x to the n minus 1. This is called the power rule. Okay? That's it. That's what you need to know. So basically what you do is you take that, for the original function, again, here's your original function, f of x equals x to the n. You move that to the front as the coefficient, and you subtract 1 from the exponent. Okay, it's actually quite simple. Okay, I just wanted to show you a little bit where it came from, because I don't just like handing you stuff. You guys need to know where things come from. All right, so let's actually do some examples here now of the power rule. If I do d by dx of x to the fifth, well, that's just putting the 5 in front and reducing it by 1 for the exponent. That's it. Okay, pretty easy. So d by dx of 5x cubed. Okay, so again, that 3 goes in the front times 5, and then you reduce it by 1 for the exponent, and so you wind up getting 15x squared. Okay, d by dx of 7x. Well, it's the same thing. It's 7x to the 1. So the 1 goes in front, so it's 1 times 7, which is 7, right? 7x to the 0. Well, what's anything to 0? 1. So it's 7 times 1, which is 7. Well, you already knew that, because remember, that was one of our, or similar to an example, y equals 7x. Well, what's the derivative of that? What's the slope of the tangent? Oh, it's 7. There we go. It's 7. Okay, d by dx of 105. Well, isn't that a horizontal line here at 105, right? What's the slope of that? It's equal to 0. Let's do it mathematically. Isn't that 105 x to the 0 power? So let's put the 0 in front. So you get 0 times 105. And then, actually, that doesn't matter what that is, but we kind of know, you should really know the derivative of a constant is 0. You really should know that. But that does come out to 0. So the derivative of a constant equals 0. Very important. Okay, let's do a couple more examples here. D by dx of 2x to the negative 3 power. Okay, no big deal. Put the negative 3 in front, so you wind up getting negative 6 x to the negative 4. And you can leave a negative exponent in there, that's fine. Alright, d by dx of x to the negative 4th over 4. Okay, well, that's just, again, moving that negative 4 in front. X to the negative, and what do you do with that? Be careful, it's to the negative 5th power, not negative 3rd. You're subtracting 1 all over 4, and that gives you negative x to the negative 5th power. Okay, how about d by dx of pi? Well, pi is a constant, so it's 0. Okay, because pi is a constant. It's irrational, but it is a constant. All right, talk about a couple more things here. Pretty simple. Sum and difference rules. Now, guys, this is just like limits. Same concept. If I said, basically it's d by dx of u plus v, and that's equal to the derivative of u, we'll say plus or minus, derivative of u plus or minus the derivative of v. Okay? So if I said d by dx of 3x squared minus 2x plus 105, even though, you know, I'm just showing it to you now, but you're not going to write that out every time, but you're really saying d by dx of 3x squared minus d by dx of 2x plus d by dx of 105. So d by dx of 3x squared is 6x, derivative of negative, or of 2x is 2, derivative of 105 is 0, so our answer is 6x minus 2. Okay, let's try one more. D by dx of 5x to the 6th minus 2 minus 3x to the negative fourth. Okay, well that's right, the 6 goes in front, so you guys agree we have 30x to the fifth. The 2 goes away because the derivative of a constant is 0, and then the negative 4 goes in front, so it's plus 12x to the negative fifth. And that's your answer. All right, and then we have constant multiple rule. And that's pretty easy. That's really straightforward too. Again, this is like limits, where you have d by dx of cx to the n. That's the same thing as c. The c comes out, right? Just like you do with limits. So c times d by dx of x to the n. Okay, so like the example d by dx of 105x squared, it's truly equal to 105 times d by dx of x squared. Pretty straightforward, right? And then, so anyway, you get 105 times 2x, which is 210x. All right, that's not too bad. All right, so a couple more things here. Let's do the second derivative. And basically that's the change in the slope. Okay, change in the slope. So just as an example, which we'll talk about a lot more later on, remember the slope, as we talked about before, would be like velocity, like miles per hour. The change in miles for every hour, right? That's the slope of change in position. Okay, and what is change in velocity? Well, change in velocity is actually acceleration, right? Okay, if I'm going 10 miles an hour and I accelerate to 15, my change is 5. We're not going to get into units quite yet, but you're accelerating or you're decelerating, you're hitting the brake. Okay, so that's change in slope or change in velocity. So, but checking the derivative is pretty easy. If I give you a basic function, y equals 3x to the fourth minus 2x squared plus 5x. All right, and so we're going to do dy by dx, and that's going to be 12x cubed minus 4x plus 5. And then the way we say second derivative, it's really the derivative d by dx of dy dx, which you write that as d squared y over dx squared. And another way to look at that is y double prime. Okay, because this was y prime here. But that's how you write the second derivative with d, derivative of y with respect to x, second derivative. Okay, but that's really easy. It's just 36 x squared minus 4. And then the third derivative, okay, and that's y triple prime if you want to look at it that way, third derivative, but that's just going to be equal to 72x, right? And y, and usually you put a 4 like this. So the fourth derivative, that's going to be 72, and the fifth derivative is going to be 0, and what's anything after that? Right, anything past that is going to be 0, right? Because derivative of 0 is 0. It's constant also. Okay. Let me ask you a question. Do you agree that if I take the derivative enough, it eventually gets to 0? Do you guys agree with that? Okay. Well, it's actually not true, right? Because if I said my function is y equals x to the negative 5, what's y prime? Negative 5x to the negative 6. And what's y double prime? That's going to be 30x to the negative 7, right? So what's happening is, obviously, if it's a positive number, it's easy because and then it gets down to 0. But if it's negative already, then it keeps getting more and more and more negative, and it never stops. Okay, so just a little thought there. All right, let's try another one here. I want you to find the first and second derivatives. And your function is y is equal to x to the negative 3 plus 2x to the negative 1 plus 5x cubed. Okay, so we're going to do y prime is equal to negative 3x to the negative fourth minus 2x to the negative 2 plus 15x squared. That's pretty easy. And then y double prime, second derivative, is going to be 12x to the negative fifth plus 4x to the negative third plus 30x. Okay, so, hopefully you got that right. Just, again, you got to follow your rules. Let's try another problem here. Find the equation of the tangent and normal lines of y equals 2x cubed minus 5x plus 4, where x equals negative 3. Alright, so it's really easy. The first thing I need to do, math fans, is I need to get a slope of that tangent line at x equals negative 3. So, to find out my slope is just dy dx, right? Change in y, we're changing x. And that's of that function right there, which is going to be 6x squared minus 5. And when x equals negative 3, you plug that into there, that gives you, again, your slope. And if I plug it in, I get 49. So that is what my slope is, 49. And in order to come up with an equation, I need an x and y coordinate. Well, I have x equals negative 3, and I need my y coordinate. And what do you plug that into? Guys, you have to plug it back into the original problem. There and there. You got to plug back in the original problem. It's huge. So plug, or to find y, plug x back into original equation. That's so huge. Because, guys, if you plug it back into the derivative, what do you think you're going to get? 49? Okay, you're going to get the exact same number. So if you plug it back in the original problem, that's going to give you your answer. If you plug it back in the derivative equation, you're going to get the slope, and you should think to yourself, oh, gee, my y value is the same as my slope value. I wonder if I plug something in wrong, all right, and figure things out. Anyway, if you plug that in the original equation, you get negative 35. All right, and so my tangent line is, again, put in point slope form. If you put it in anything else, you're crazy and you're doing a lot more work. Okay, but it's going to be y plus 35 equals, the slope is 49 times x plus 3. The normal line, that's why when it's in point slope form, it's really easy. It's y plus 35 equals negative 1 over 49 times x plus 3. Super easy. Super, super, super easy. Okay? All right, one last thing I want to do with you guys is find the horizontal tangents of y equals 2x cubed plus 23 halves x squared minus 4x. Okay, so find the horizontal tangents of that nasty, nasty formula. Well, do you guys remember a horizontal tangent is what? Where the slope equals 0. So let's take the derivative of it. dy dx is equal to 6x squared plus 23x minus 4, and set it equal to 0. It's quadratic. This one actually factors nicely, and if it didn't, you'd use the quadratic formula. 6x minus 1, x plus 4 equals 0. So x is 1/6, and x equals negative 4. Okay, and if I'm asking you to find the horizontal tangents, I'm asking you guys probably to give me a coordinate. I might ask you for the x coordinate, then that's your answer right there, 1/6 and negative 4. But if I ask you to find the x and y coordinate, you're going to plug it back into the original formula. Use your graphing calculator, give me a nice, use your fraction button. Anyway, you get 1/6 comma negative 73 over 216. and the other one is -4, 72. Okay? And that is finding your horizontal tangents. Now I want to show you real quickly with your graphing calculator. So I'm going to bring up my virtual TI here. And I want to type in this equation, y equals, right? So let's clear all your stuff out of here. And if I do y equals 2x cubed plus, and use lots of parentheses here, 23 halves x squared minus 4x. Okay, that's pretty reasonable. And again, I'm trying to find the horizontal tangents of that line. So I'm not going to use end deriv now. I just want to actually just show what this is going to happen here. So if I hit zoom 6, okay, well, it's kind of covering up our horizontal tangents. Here's one over here in the middle, right, where that probably that 1/6 is. So let's actually zoom out. Let's make our window -5, because I want to show you what it's going to look like. -5 to 5, and -1 for the y. -1 to, and well, we got to see at 72. We got to go up to at least 75. So let's go to 75, and then we'll graph it. Ah, there it is, man. There's our graph. Oh, what a sweet looking graph. So do you guys agree? Right over here on the top, right? This is our horizontal tangent. It'll be at a maximum minimum. We actually even talked about this already. So it's a maximum minimum. Well, let's actually use our calculator to figure that out. And if I hit second calculate, and I'm going to do a maximum. Let's do the left side first. So I'm going to do a maximum. And it says the left bound, so you're going to take your little cursor here, and you're going to go to the left side of that curve. Make sure you're on the left side. Okay, it looks good. Hit enter. We're going to go to the right side of the curve. And hit enter. And guess. And we get x equals negative. There it is, negative 3.99998. So it's -4, 72. Hey, there it is, man. Right there, -4, 72. Now, just because we're going to check it here in a little bit, let's figure out, just on our calculator real quickly, -73 over 216. So let's actually quit out of here. -73 out of 216, or over 216. So it's -0.33796. -0.33796. Okay, and let's use our calculator now back to our graph. And I'm going to look at that bottom part. See, I want to find the minimum, so I'm going to do second calculate, and we're going to do a minimum value. Minimum, and we're going to enter, and left bound, let's get closer to the bottom of the curve. Hit enter, go to the right side, past the bottom of the curve, and then guess. And there it is, 0.1666667, which is 1/6, and there it is, -0.33796. Sweet, sweet. So those are our values. So anyway, just using your graphing calculator to actually find things out like that, your maximum minimum. We're going to be doing a lot of investigation of graphs in future days here, but I just want to show you one where you got the solution. But you know, it's just kind of interesting. All right, that's it, math fans. Have an outstanding day. Adios. Goodbye.